So now we're going to look at some examples that might help with the worksheet. Absolutely, that is homework for this weekend. The first example is the absolute value of x equals 2. Now, with all of these examples and the ones on your worksheet for numbers 1 through 6, you need to solve the absolute value equation or inequality and graph it on a number line. So for this one, let's think about what values of x would make this true. Well, we could see that the absolute value of 2 would be 2, but also the absolute value of negative 2 would be 2. So our right answer or solution would be x equals 2 or negative 2. You have to include both of these, and you always put an or in between when you have two different solutions. On a number line, we would need to include the important numbers negative 2, 0, and 2. Remember, the 2 and negative 2 are called critical points, and those are the ones where the circles will go, either the open or closed circles. In this case, x will actually equal 2 and negative 2, so we want to make sure that we do a closed circle at both of those. Now, this one's actually not too bad because it's not an inequality, so we don't need to test any points. Those two are the only solutions. X can only be 2 or negative 2. However, let's do one with an inequality. We'll do the absolute value of x is less than 2. Again, we are going to have negative 2 and 2 as our critical points. This time, notice, though, there's no or equal to on our sign for our inequality, so it has to be open circles. These open circles are really splitting your number line now into 3 sections. Imagine a little line going down through the circles. Then you can see the 3 sections that it's splitting it into. We have this section here, which is everything less than negative 2. We have everything in between negative 2 and 2. And then we also have everything that's greater than 2. We need to test a point in each of these 3 sections. When we test the point, we can plug it back into the original inequality. So, in this area, let's choose a number less than negative 2. Negative 3 will do. Negative 3 is less than 2. Well, the absolute value of negative 3 is really positive 3, so we have positive 3 is less than 2. That is definitely not true, or false, as we've been saying. So we cannot do that part of the graph. We do not shade in that region. Remember, the shaded region represents solutions that will work, and this one we just saw will not work. An easy point to always test in between 2 critical points is 0. The absolute value of 0 is less than 2. Well, the absolute value of 0 is still 0, and 0 is less than 2. So this is true, which means we better shade this section of our number line. Finally, we are on this section. Let's test 3. The absolute value of 3 is less than 2. Well, the absolute value of 3 is just 3, and 3 is not less than 2, so this is false. This means that we cannot shade this region. Therefore, only this region here in the middle, in between negative 2 and 2, will work. When our solution is sandwiched in between our 2 critical points, we actually write a sandwich of an inequality for an answer. In fact, the lowest number x could be is negative 2, and then the highest it could be is 2. And then we put x right in the middle, and we know that x has to be greater than negative 2, but less than 2. If you're actually reading this statement, you would say negative 2 is less than x, which is less than 2. You will see this a lot when x has to be between 2 values. Let's do another example. I'm going to minimize this one just a little bit so we have some room for some more examples. Okay, so the next example that we're going to do is the absolute value of x is greater than or equal to 4. Well, our 2 critical points are going to be negative 4 and 4. And this time we see that it's or equal to, so we need to have closed circles. Remember, the purpose of these circles and these critical points is they're really like imaginary numbers, splitting our number line into 3 sections. We need to test a point in each of the 3 sections. So here we go. A number that is less than -4 could be -5. So let's plug in -5. The absolute value of -5 is greater than or equal to 4. Well, the absolute value of -5 is 5. And 5 is greater than or equal to 4. So this is a true statement. Therefore, we need to shade this region of our number line. And that means that any number that is less than -4 will work. Again, 0 is an easy one to plug in when you're doing it between the 2 critical points. So if the absolute value of 0 is greater than or equal to 4. 0 is not greater than or equal to 4, so this is false. Therefore, we cannot shade this section of the number line. Now here we have another example, or another region that we need to test. So let's do 5. The absolute value of 5 is greater than or equal to 4. This is the same thing as 5 is greater than or equal to 4, which is true. So we do need to shade this part of the number line. So you can see we have 2 regions of our number line that will make this equation or inequality true. We have everything that is less than or equal to -4, and we have everything that is greater than or equal to +4. How we would write that as a solution would be we actually break it into 2 parts. We first look at everything on the left region that satisfies it, and that would mean that x is less than or equal to -4. Now, just like in our first example, we would write OR if there's more than one region that works or more than one solution. Our other region is on everything that is greater than or equal to 4. So we could write x is greater than or equal to 4. This is our answer. I'm going to do one more example that I think might help some of you on the worksheet. So my last example will be, let's do x is less than the absolute value of -1. When the absolute value is around a number value instead of a variable, always simplify first. In fact, we know that the absolute value of -1 is really 1. So this is saying the same thing as x is less than 1. Now this seems like an easy inequality to graph. In fact, this is just like the answers we used to have when we were doing inequalities in Unit 5. If we do our number line, we're going to have 0, of course, on our number line, but the only other critical point we have here is 1, because x is not inside absolute value bars. And I see that it is an open circle. Let's double check that we can shade the correct side of our number line by plugging in different values from the 2 different things to the original equation. So here, if we plug in 0, we have 0 is less than the absolute value of -1. 0 is less than 1. That's true. So we know that this side needs to be shaded. Just to double check, I want to make sure something up here doesn't work. So let's do 2. 2 is less than the absolute value of -1. 2 is less than 1. This is not true. This is actually false. So we do not shade that region. So our final answer is this inequality, because that shows what we have shaded on our number line. X is less than 1.